We'll now look at the second type of telescope to be invented, which is the reflecting or reflector telescope, which is made with mirrors. And so because a mirror reflects light, these telescopes are called reflectors. The first person to invent a reflecting telescope was Isaac Newton, and so his telescope design is called the Newtonian telescope. And in this case, using mirrors, we have a main mirror called the primary mirror that is curved, and it's curved so that when the light comes in and hits that curved surface, it reflects inward. So similar to how a lens bends light inward, a reflecting telescope reflects light inward. Now, ideally, where our light rays are moving inward is where we would want to put our eyepiece. However, that would mean sticking your head in front of the telescope. So Isaac Newton came up with the idea of suspending in the middle of the telescope a flat mirror called a secondary mirror, and that flat mirror reflects the light out the side of the telescope, and that's where you would put your eyepiece. So that design works quite well. Many years later, a man named Cassegrain came up with a different design. He looked at the Newtonian design, and because there is this secondary mirror here, when light comes in, behind your secondary mirror, you are going to get a shadow. So no light is hitting that part of your primary mirror. So Cassegrain said, well, okay, if I'm not going to use that part of my mirror, let's just cut a hole in the mirror. And instead of reflecting the light out the side, let's reflect it out the back of the telescope. So in a Cassegrain design, the light comes in, hits our curved primary, reflects the light inward. Our secondary mirror is slightly curved and reflects the light through that hole, and back behind would be where the eyepiece is located. I've cleaned up my picture to illustrate our telescope focal length in this case. Now recall, with a refractor, it was the distance from the lens to the focal point, where the focal point is where the light rays cross. So the same thing is going to be true with a mirror. It's going to be the distance from the mirror to where the light rays cross. And the same thing for a Cassegrain, from the mirror to where the rays cross. So that principle is still the same, just looks a little different because of the design of the telescopes. So we're still going to use the same equation, that our magnification is going to equal the telescope focal length, divided by the eyepiece focal length. And it's still an inverse relationship, so as the eyepiece focal length goes up, magnification goes down. So all of that is still true. And it is also still true that for every inch of aperture, expect to get at most 50 power of magnification. Where now your aperture is based upon the mirror size rather than the lens size, but it's the same idea. How big across is your telescope? That's going to be your aperture. And so, again, if you have a large aperture telescope, you'll be able to effectively get more magnification than if you have a small aperture telescope. In the next installment, we're going to look at comparing the advantages and disadvantages of reflectors versus refractors.